Broadcast is now starting. All attendees are in listen-only mode.
All right, we're going to go ahead and get started. Good morning, everyone, and welcome to the November California-Nevada Drought and Climate Outlook Webinar. Thank you for those that have joined us previously and those that may be joining us for the first time. My name is Amanda Sheffield, and I am the Regional Drought Information Coordinator for NIDIS for California and Nevada. And we host this bi-monthly webinar series with the California-Nevada Applications Program, a NOAA RESA team. This series is designed to provide the region with timely information on current drought status and associated impacts, as well as a preview of upcoming climatic events. This webinar is being recorded, and the recording will be available later this week on drought.gov, likely within 24 hours. Just a little bit about NIDIS for those who may not know, or just a reminder. NIDIS, our mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources. And we work to improve our understanding of how and why droughts affect society, the economy, the environment, and improve accessibility of information, including early warning information for drought risk management. We try to achieve this goal by building the foundation of a national drought early warning system through development of regional drought early warning systems, which California and Nevada is one of them. And each of these systems have activities under prediction and forecasting, research, planning and preparedness, collaborating with partners, and also the U.S. drought portal, drought.gov, which is the home base for a lot of NIDIS information. As I mentioned, California, Nevada is one of these regional systems, so we work closely with our partners, new and developing partners that we get closer to make sure the information specifically for California, Nevada is readily available, easily understandable, and usable for decision making. And we want to make sure you can better monitor, plan for, forecast, and cope with the impacts of drought. And so, for example, these webinar series are one of those things we do under communication outreach in the regional drought early warning system. But that's enough about NIDIS. So I just then want to hop over to what our great agenda is today for the webinar. Obviously, right now we're on the precipice of seeing what this winter is going to turn out to be. So the first presentation will be by Dave Simmerall from the Western Regional Climate Center. He's going to provide the drought and climate update. Then I will provide a little bit of outlook information, and then we're going to be following with tools and resources for your winter toolbox. So myself and Julie Kalansky will talk about some tools, and Julie specifically will talk about CNAP tools and the Center for Western Weather and Water Extremes tools as well. With that, I will pop control over to Dave. Dave, you there?
Yeah, I'm here. Can you hear me?
Yep, you're good.
Okay. And you can see my screen?
Mm-hmm.
Okay, thanks, Amanda. Just a quick outline of my presentation. I'm going to talk about the current drought status, and I'm going to give a retrospective look at how we arrived at where we are now. I'll go over the summer heat wave, talk about the current conditions in the water year. Then I'll talk a little bit about our current ENSO status, as well as La Niña precipitation relationships, and then the drought outlook. So here we are currently. This is the current Western drought map from the U.S. Drought Monitor. As most of you know, the darker, warmer condition or colors on the map represent more intense drought, and you can see right now we've got about 76% of the Western U.S. Is currently in drought. 71% of California is in drought, and 99% of Nevada is in drought. Impacts that we've been seeing around California, up in the northeast part of the state, They've been experiencing poor rangeland conditions over the summer and stock ponds that are dry. Similar type of impacts that we're seeing up in the Sacramento Valley, including low groundwater levels. In Nevada, and by the way, this is a map from the National Drought Mitigation Center, which shows drought impacts. This is the Seymour system, and this is just a screenshot of the current locations in California and Nevada that are reporting drought impacts, and you can see quite a bit in Northern California. Not much, that doesn't mean there's not impacts being observed, but just not a lot in the way of reporting. So this is looking at the change maps according to the US Drought Monitor maps. So on the left-hand side, you're looking at the last 3 months. So this is from the period at August 25th up to the last map. And these are the classifications. You can see the warmer colors. These are degradations in drought intensity. So you've seen over the last 3 months, we've seen some degradation in the northern part of California, as well as across central, and the most degradation we've seen is in southern parts of Nevada and kind of the eastern Sierra extending down into the southeast deserts. Looking at the last 6 months, this is looking from the beginning of the summer. You can see most of the deterioration has occurred in southern Nevada, in east central Nevada, and that's primarily in relation to two things, the intense heat this summer, but also kind of the failed monsoon season we had, where this area in kind of eastern, east central Nevada, southern Nevada, as well as in the southeast deserts, they get about roughly 15 to 20% of the annual precipitation comes during the monsoon season, which was a really poor monsoon season this year. Looking back at how we arrived here is again the current Drought Monitor map, and these are from Westwide Drought Tracker. This is looking at the last water year, and this is looking October 2019 through September. As you can see, this is percent of normal precipitation, and you can see where the drought is most intense in these areas in central Nevada, eastern, east central, northern California. These are also the areas you can see here over the water year that were pretty much less than 60% of normal, and in some areas less than 40% of normal. This is looking at a percentile ranking, and you can see record dryness in east central and central Nevada, and some areas in the northwestern part of Nevada, as well as in northern California, where precip fell into the top 10% driest. Southern California, in the southwest corner down in San Diego and the southwest deserts, they were above normal in those areas. Looking at the snowpack, this is on the left-hand side, this is SWE, snow water equivalent, and these are the percentiles. This is as of April, excuse me, April 1st, 2020. And you can see across pretty much most of the region, we had well below normal snowpack during the winter months, except for some areas up in the kind of Santa Rosa's and Independence Mountains, as well as the Jarbidge up in northeastern part. And then these are the by drainage basin, the percentage of median, and as you can see, pretty much below normal across most of the region, near normal up in kind of northern Nevada and in northern Lahontan. And what kind of led into the drought development this summer, we had, besides below normal precipitation through the winter, we had an early melt out. And if you can take a look at these three images. This is April 1st, May 1st, June 1st. This is just snow depth. And you could see how quickly by June 1st, basically all the snowpack was gone. And that was a product of, we had several, I wouldn't call them heat waves, but, and this is just to kind of provide an example of the observations. This is at South Lake Tahoe, and these are the obs for each of those months. And you could see towards the end of April, we were pushing near record temperatures at the end of April. Moving into May, we had another warm period. We're pushing record temperatures, and you can also see the minimum temperatures were above freezing. And this is like at lake level at 6,600 feet or so. And then moving into June, again, more warm temperatures. So we had a premature melt out. Moving into the summer months, we, as most of you know, we had record heat. This is looking at mean temperature percentiles, August, September, October. I put a couple highlights for each of the months of things that were notable. In August, you could see most of the Southwest, Intermountain West, California, Nevada were all experiencing record heat or heat that fell in the top 10%. In August, again, records broken across the West. We had the highest temperature possibly ever recorded, and that was in Death Valley during early August. We also had some thunderstorm activity, mainly dry thunderstorms that started all the fires in California. Moving into September, the record heat continued. We had very hot temperatures around the state of California. LA County had its highest temperature recorded of all time, hitting 120 in Woodland Hills. Las Vegas experienced its second, or tied for its driest monsoon season on record. And then moving into October, totally dry throughout the month, almost no precipitation across our two states and more record heat. I just threw this in. This was a photo from that, this was the remnants of the post-tropical storm Elida that moved up the California coast. This was coming on shores about 4 in the morning. I didn't take this, but grabbed this off of Twitter, but I thought it was a pretty amazing photo. This was the dry thunderstorm event that started all the fires. There were about 8,500 lightning strikes within a 3-day period in central and northern California. So some context looking at average temperature. This is August through October. On the left here, these are the Climate Division rankings for that period. So for that 3-month period, you could see we had record heat for that 3-month period, where all these deep red colors are. Those are all records for those climate divisions. And on the right, these are the temperature anomalies. So you can see we were in all of these climate divisions, we're looking at 5 to 7 degree above normal temperature anomalies for that period. Looking at from May until October, these are the statewide rankings for that 6-month period. And you can see California had its warmest 6-month period of May through October on record. And Nevada had its second. Again, looking at the anomalies, these are averaged over statewide, but you can see California was well above normal in terms of temperatures. Precipitation-wise ranking, this is the May through October, looking at that 6-month period. Driest on record for statewide for Nevada, 7th driest in California. And then this is looking at the regional breakdown. And it's not that surprising for that period, May through October. Generally speaking, there's not much in the way of precipitation. Sometimes in May, and some can fall in October. But the main thing is during that period, during the monsoon, during July through September, very dry in southern Nevada, as well as in the southeastern deserts. This was passed on by a colleague today, one of my fellow Drought Monitor authors, these stats in terms of days since last measurable rainfall. Bishop, it's been, and measurable rainfall is more than 1/100 of an inch. It's been 220 days that Bishop hasn't had precipitation. Las Vegas 217, Needles, California 210. So moving to the current water year to date, on the left, this is looking at October 1st to present, and you can see this is a kind of typical La Niña pattern that's kind of evolving, and you can see well below normal precipitation across California, most of Nevada, as well as in the Southwest and Intermountain West, and you can see above normal precip up in the Pacific Northwest and Northern Rockies. On the right, these are the percentile rankings to date. Actually, this was as of the 21st. The snowpack's not doing too bad around the Tahoe Basin area. Drier, much drier down to the southern Sierra and parts of the central. In Nevada, kind of a mixed bag up in the northeast part of the state, as well as in the Rubies. This little inset map here, this is the water year to date precipitation for SNOTEL sites, and you can see pretty much all below normal across all the SNOTEL sites. And this is kind of a blown up version of that image, and you can see for the water year to date precip around Lake Tahoe Basin to the south, we're seeing below normal precip at all the stations, as well as over in eastern Nevada in the Ruby Mountains, as well as like the Egan Range, over in the Toyabe's, up in the Jarbidge, as well as the Independence Mountains, above normal precipitation up in the Santa Rosa Range, up in the kind of central, west central part of Nevada. And then these were just a couple screenshots I grabbed this morning from the alert wildfire cams, just looking at snowpack conditions. Upper right left, this is up on Mount Shasta ski area. This is probably a little over 6,000 feet in elevation, pretty thin snowpack there. Right below that, Cave Mountain, this is in the Shell Range, and this is looking east at, this is Great Basin National Park, Mount Wheeler. This is at about 10,700 feet, thin snowpack there. These are just a couple little screenshots I grabbed of SNOTEL site data, and just kind of looking at how many precip events have occurred in this. In general, it's been about 3 to 4 precip events have occurred since the beginning of the water year, with and mainly that's all happened in November. You can see this is Heavenly Valley, South Lake Tahoe. Tahoe Basin got a little bit of a dusting. We had a weak low that moved through last night, and another one expected not to bring much in the way of precipitation coming up over Wednesday night into Thursday, but nothing really looking ahead. And you can see the lower elevations around the lake are pretty much no snowpack. Around the lake, we're looking at ranging from about 6 inches to 20 inches of snow on the ground at the higher elevations.
David,
so we have
3 to 5 more minutes.
Okay, so I'm going to let Amanda's got a few slides on the La Niña advisory, so I'm going to skip over these and kind of talk about what it means for us in California and Nevada in terms of precipitation. These are this map here is, it looks at La Niña events, moderate La Niña events, and the percentage of normal precip. As you can see, northern parts of the state generally are kind of a little bit above normal, and as you go further south, you get a more of a below normal signal, which is typical of La Niña. Each one of these are looking at climate division, different climate divisions in California. This is precipitation on the y-axis, and these are basically looking at whether it's El Nino, neutral, or La Niña. And this black line is the average precipitation for that particular climate division. Each of the other colors here, that is the average. And you can see they're all clustered together for northwestern part of California Division 1. But you can see I've highlighted the moderate El Nino or La Niña events, and you can see most of them are above normal precip. We've got a few below. Moving into, let's go to Southern California, you can see a clearer signal. You generally get below normal precipitation. And then looking at Division 7, same thing, below normal. Moving into Nevada, for northwestern Nevada, you're kind of getting, you can kind of go either way, below normal or above normal precip. Moving into central, and I didn't include southern, you get a clear signal to below normal precipitation for moderate La Nina events. And then looking at the drought outlook, moving ahead, this is the latest CPC map going through February 28th. And with the current La Nina conditions in place, we're expecting deterioration in conditions and drought to persist across much of Nevada and California. We're expecting some improvement in northern parts of extreme northern California and northern Nevada, and drought likely develop in kind of the central coast area, extending down into Southern California. And then looking at the next 8 to 14 days, we're expecting below normal precipitation during that period. Not much on the horizon in the shorter term. And that's about it. Thanks much.
Thanks, Dave. We do most questions at the end, but there's a quick one. I think they want to clarify the SNOTEL plots on your, the small ones on your photo slide. And I want to make sure I clarify if this works. She was thinking the red was the current snowpack, but I wanted to clarify that that's, I couldn't remember if it's the normal or previous year for folks. Yeah, so the black line, just to match this person's question, is the current year, and the red line, is that the normal, Dave, for that location? Oh. Maybe he got muted. Dave, I think we can't hear you, so I can follow up with the person offline, but I'm pretty sure, I think it's one of
I'm sorry. I was muted. Sorry about that.
No worries.
So yeah, the black line is the current accumulation, and the blue line is the current SWE. And then basically this is just looking at the average right here, snow water equivalent, the median, excuse me.
Right. Thanks, Dave.
Thanks.
For time, I'll move on to the next, to me, for the Outlook presentation. We'll catch any other questions at the end. All right. All right. So as Dave mentioned, I'm going to do a little bit on the Outlook information, but obviously he hinted that we're in the current La Nina conditions, and he talked a little bit about what that's meant in the past for us. And so, I mean, I want to start before I go into a little bit of the forecast and the outlook to mention that we pay so much attention to ENSO because it really does tend to affect the global weather and climate, especially when it's stronger. And it mixes in with other oscillations and conditions and things like that to get to the forecast that we get to. But it has been shown to be a driver, especially in the southern part of our region. And I was looking up some information from the National Weather Service and climate.gov on ENSO and things like that. And there are already some pretty clear signals for the La Nina impacts of the teleconnections for them, such as doesn't impact California and Nevada as much, but the hurricane season with the active hurricanes we had this year. That's sort of a signal of La Nina, as well as they're seeing some precipitation and temperature patterns all the way in China and the U.S. Southwest, and cooler weather in Canada and the Northern Plains. Those are all sort of signals that La Nina is here. So just go back. This is a table that goes back to La Nina and El Nino periods, going back towards 2008. The La Nina periods would be here in blue, and the El Nino periods here in red, and the neutral are the gray ones in between. Just to give you a sense, here in 2020, obviously we've had El Nino conditions before, and it takes several time periods of these monthly periods to sort of link and say, this is La Nina, etc. But we can see we're already getting very close to this negative 0.5 is what they use as a threshold. And we're getting there pretty consistently in these La Nina conditions, hence why they've been talking about it. And just to go into a little bit of the forecast for La Nina before we show what does that mean for temperature and precipitation, that La Nina is being forecasted by the Weather Service to continue in the Northern Hemisphere for this winter, about 95% chance continuing through January to March, and 65% chance continuing into March to May of next year. So the figure you're seeing here just goes by goes through the season here. We're right about here in this time period. And there's a bunch of different models and what they are saying either for neutral La Nina or El Nino conditions. And I highlighted here in blue how many of them, and hence the consensus is that La Nina conditions are here and they're here to stay for quite a bit of the winter and into the spring. So this just sort of summarizes that the conditions are present. We see them from the equatorial sea surface temperatures, then that causes the tropical atmosphere and other teleconnections to show signals of La Nina, and it's forecasted to continue. And as here, we're trying to give you guys the resources to track these kind of things as we go through the winter. So this is the website, for example, from the National Weather Service Climate Prediction Center, where you can read more about details about ENSO, or also I find very user-friendly is their ENSO blog. It distills the information that's coming out of the models and from the forecasters and things to let you know what's coming up with ENSO. So what does this mean for our temperature and precipitation outlooks? I usually like to start this time of year to remind folks, how do you read these graphics or figures? You often see a version of this from the National Weather Service. This is our December, January, February temperature outlook. Forecasters put this together using climate information and what the forecast are showing. And so this one actually has pretty clear signals of what what temperature would look like with La Nina conditions. And so the shading represents the favored category or favored probability of what's going to happen in that region. So different parts of here could have above normal, below normal, or equal chances of above or below normal conditions. Or near normal, sorry, there's a third category, near normal. And so for different locations, depending on the color is the predominant category. So for example, here in Los Angeles, right now the forecast is for above 45% chance of above normal temperatures. But you still could get below or normal chances. You're just you're favored to have above normal temperatures, and a little bit lesser percentage up in, for example, Reno. It's in this lighter orange area here, which is about 39%. And so this was made November 19th, so it was just hot off the press last week. And as we move through the seasons, here December, January, February, then January, February, March, April, we see pretty consistent patterns and signals here where you expect to be pretty warm in our region throughout the winter and into the early spring. And your odds are higher the more southern part of the region you are. And then to look at precipitation, so this is similar to that, but instead of blues and oranges, you have browns for drier or below normal precipitation, and greens for above. And these follow La Nina patterns as well throughout the season in our region, where the more southern you are, the higher odds are currently for being drier compared to normal, so below normal precipitation. And then Dave showed this. That sort of leads to the current seasonal drought outlook, which also came out last week. So a lot of the region is expected for drought to persist and drought development to be likely in that what was left in California that wasn't in drought in the southern and central coastal areas. So most of those are sort of what our forecast models are saying, and you'll get a little bit more about experimental products from Julie, who's going to talk about some from the Center for Western Weather and Water Extremes. But one I wanted to point to here is a tool that uses more like statistical methods. So it looks at the history that we received precipitation in our region, and then determined whether what are the odds of reaching 100% based on what's happened in the past. So, for example, as of November 1st, there's still quite a bit because we haven't gotten a ton of precipitation yet, as Dave showed, compared to normal. Our odds are pretty low right now that we may reach 100%. This can change if we get more, and then the model will recalculate, and you'll think about it again about, well, how much do we actually have odds based on what we've seen previously of reaching 100% of normal water year precipitation. But right now, as of November 1st, this is what it looks like, with quite a bit of reds and yellows in here. And this will update monthly, so on November 1st at this link, that's CW3E. So just in summary here, before I pass it over to Julie to show you some tools, La Niña is here, and it's likely to continue through the winter, about 95% through January to March, and through the spring of 65%. I just want to remind you that ENSO is one part of the subseasonal seasonal forecast toolbox. They have a lot of other information they use. We'll have to wait and see a little bit more as we get deeper into the season about how it happens and things like that. And we are favored to have above normal temperatures and below normal precipitation, especially the more southern you are in California and Nevada. And I recommend keeping up to date with your local weather service office for your shorter term forecasts, as well as us, the Climate Prediction Center, for longer term forecasts and things like that. So we'll continue to provide you guys information throughout the season. And with that, I will pass it over to Julie and check and see if there's any quick questions. But so Julie's going to provide sort of through web pages a little bit of the tools and things to add to your toolbox from CNAP and CW3E, and then I'll come back at the end to give you more of a thorough list of some tools and things to show you guys so you have them in your toolbox for the winter.
Okay. Good morning. Can everybody see my screen here?
Yes.
Okay. Okay, great. So I'm actually not going to be using a presentation and just going to be going through some websites because I thought it'd be easier so you could actually see the tools. So the first one is on the CNAP website, and it's just cnap.ucsd.edu. And if you go to the observations and track down here, this is where all the tools are located. And so this first one is precipitation tracking in California and Nevada. And so what it shows is when we have a storm, this is for San Diego County, and you can see what stations, this is based on station data, what stations make up the region. And so what you can see is the current percentage of precipitation, the 1-day change, which is 0 because we haven't had any, this 2-day change. So if you've had a storm and it's rained over 2 days, you can see that change, or a 3-day change. And this is, and it will tell you what percentile it is. And so the 50th percentile for 1-day change is 0.37% increase. And so you can see that going forward. A 99th percentile change for 1 day is a 9.18% change. And then the record for 1 day is a 26.67%. And so you can see that, for the different change in days. And then you can also, and it has different regions. So this is Los Angeles here. Here's all of California. Here's the 8-station index in Northern California, which is important for snowpack and water supply throughout California. This is for Clark County, so the Las Vegas region. And this is for Reno, Carson City. And then if you click on the images, you can actually see them a little bit larger. And so this is for the Reno, and so you can see other years. So this is, the green is 1972, 73, what percentage of normal, and then you can see where we're tracking this year. And the bottom one is similar, but all years is the light blue, 2/3 of the year is the stark blue, the median is the dashed line, and you can see how we're tracking this year. And so this is one way just to see how the region is doing for precipitation. And so another one is this water storage tracking, which is done by Mike Dettinger. And so it combines both snowpack plus reservoirs to look at how much water is available. And so Mike Dettinger updates these regularly and posts them to the website. You can also follow Mike Dettinger on Twitter, and he posts them there. I will note that the Sierra Snowpack hasn't started posting to the California Department of Water Resources website. So right now we're just seeing the reservoirs, not actually the snowpack as well. But this is the combination of reservoirs and snowpack, because combined that really is our water supply. And so Mike does this for several different locations. He splits the Sierras into northern, central, and southern. And again, because the snowpacks aren't registering, we're just seeing reservoirs here. The upper Sacramento, and you can start to see that there's been just a little bit of snow with precipitation we had, I guess it was about 2 weeks ago or last week. Here's the Yuba Feather River storage system. The Lake Tahoe, you can see where Lake Tahoe is, still above normal. And then he also does this for the upper Colorado. And so this first one is just for the reservoirs upstream of Lake Powell, so snowpack plus reservoirs. And then this last one also includes Lake Powell. So you can see where Lake Powell is in addition. And then, so this is an indication for water supply. Another one is the UCLA Drought Monitor. And so what the Drought Monitor does, it's a modeled, and so it takes the current conditions and runs it through 2 separate models. So one is the VIC model and one is the OMP, and you can see how the total soil moisture compares to other years in the past relative to today based on, so it's a percentile. And some of the reasons that they're 2 models is that hydrologic models, by areas where they're showing similar results, you know that there's more confidence in it. Areas that are very different results, there's less confidence in, you know, the current conditions, as soil moisture can be difficult to model at times. So you can also see this for total moisture, you can see this for soil moisture, and then also for snow water equivalent. And because there's very little snow right now, you're seeing the low percentile. And then the last one, again, these haven't all started updating, but you can also see the percent of normal for SWE for different areas. So the Central Sierras, Northern Sierras, and Upper Colorado. So next, I'm going to move to the Center for Western Weather and Water Extremes website. So it's cw3e.ucsd.edu. And there's quite a bit of information here. Oftentimes, I'll start by going to forecast of ARs, IWV, which is Integrated Water Vapor Transport, and IVT. So these forecasts really highlight the importance of forecasts on atmospheric rivers, as they can bring a large majority of the precipitation to California and also into Nevada. And so up here, what you're seeing are maps of IVT, which is one of the main ways we measure atmospheric rivers, and there's different models on the side. There's the GFS, which is the US national model, the ECMWF, which is the European model, and the NAM, which is a higher resolution model. And then so if you scroll down, what you can also see is these are ensemble plots. And so if you click on this plot, what this is showing is the probability or the number of ensembles that are showing atmospheric river conditions, so IVT above 250 kilograms per meter per second. What the percentage of ensemble members, so this is it's a weather forecast model that's run multiple different times, and so the percentage of those different runs that are showing it for different locations, different latitudes along the US West Coast. And then what you're seeing here is the likelihood of AR conditions from 0 to 72 hours, and at the 99, 75% or 50% of the model showing it at the different latitudes. And so it just gives you a sense of how certain the forecast is that the AR is going to be hitting. So, and it also gives a longer lead time, though I will note, you know, that in these long lead times beyond day 7, there's a lot of uncertainty out here. But it does just give a sense of whether or not something might be happening. But take these longer lead times with a big grain of salt, in that they don't always verify. So another thing that CW3 has produced this year is these AR scale forecast. And so I will click on this, and this is a video that you can watch that explains what the AR scale is and how to read the forecast. But what this is showing the AR scale, and so the strength of an AR, both in maximum magnitude, and duration. ARs 1 and 2 are generally beneficial in terms of bringing water. ARs 4 and 5 have more of a likelihood to be hazardous. So this does depend on antecedent conditions. If there's, there have been many ARs, or how saturated the soils are. And so this is what has happened in the past 7 days, so the observed, and this is what happens in the forecast. And you can turn your precipitation on and off, so the precipitation goes off. You can change between the US model, the European model, and there's also an inland transect where you can see what's coming. The plume diagrams down here give you a sense of what has happened. So again, you can do coastal or inland, and I will just go to a location that has an AR in the forecast. So you can change your latitude, and the dot changes here, and you can see approximately where it is. And so what this is showing, and this is the atmospheric river that was an A, and so this was an AR2 associated with the green, and the black is what had happened. And then you can see here is that this is the maximum strength. This is the A here, and the duration. And then over here is the B, which is in the forecast period. So that over these are the future 7 days, so the forecast period. And this is the B, it's between 24 and 48 hours, and it's of moderate strength, so it's an AR2. The black line is showing the control. And then all the other gray lines are showing different ensemble members. And the green is the mean of all those, the average of all those ensemble members. And the blue is the one standard deviation, and the red is a +1 standard deviation. And so this just gives you a sense of what's coming in terms of atmospheric rivers, and then also the strength and the potential impacts for them. Another thing on the CW3E website, which is new this year, is the sub-seasonal to seasonal forecast. So most of these are focused in the sub-seasonal time frame. And so this is looking at the probability of atmospheric river occurrence, and this is in week 1. And each one of these shows the probability of having an AR. And you can click on each one to get a more zoomed in image of it. And then you can see the scale down here. So between 0 and 10 is white, and then it increases going from yellow to green. And here is week 2. And then in week 3, what we show is just relative to climatology. And so this is what the forecast for number of AR a day is. It's about a day and a half. This is what the climatological forecast is. And so relative to climatology, the week 3 forecast is that there's about 1 extra day of atmospheric river conditions in this blue area. New this year is a ridging forecast. You can change what a ridge sets up. It often leads to dry conditions over California and Nevada. And so you can change your forecast period from weeks 1 and week 2 to weeks 3 and 4, likewise to 5 and 6. I will, for right now, leave it at weeks 3 and 4. And so this is each one a different ensemble member showing the ridging, the daily ridge counts. So how many times it's anticipated to see this type of ridge. And the image here shows the precipitation anomaly. And then this is because less than 50% of the ensemble members are not forecasting in weeks 3 and 4. This type of ridging, it's faded out, meaning there's not much certainty in this forecast. And so this is true for all of weeks 3 and 4. Let's see. So for example, for weeks 1 and 2, there's more certainty in the South Ridge type, right? A lot of these are above the climatology. And so there's ensemble agreement, and this is a precipitation pattern that is associated with this type of ridging. Likewise, in weeks 1 and 2 for the West Ridge type, this is also the precipitation anomalies associated with it, and it's a 56% chance. The last that I will just mention that Amanda also highlighted is this odds of reaching 100% of normal water year precipitation. And so there's a whole web page. These are, you can go back once throughout the year. You can see how this has changed throughout the water year. This is the odds of reaching 100%, but then also these are also produced for different percentages. And so if you want to dig into a little deeper to what Amanda presented, this is where you can find more information. The one thing I did forget to mention is that for each of these sub-seasonal forecasts, they're based on publications. So it looks at the hindcast skill assessment of these, which are linked on this page. And so if you want to read more about the forecast or the methods or anything, there's the publication that you can read and learn more about it. The last website that I would like to highlight is the Great Basin Dashboard. So the Great Basin Dashboard, there's the current conditions. This is often where my go-to just to get a quick glance as to what's going on in California, Nevada. You have the Drought Monitor, you have the Palmer Drought Severity Index, Vegetation Drought, Veg Dry, and then also you can see the temperature departures all over the West. These are for the Western Regional Climate Center for the last 7 days, 30 days, 90 days since the start of the water year and over the last 12 months. You can also see it for precipitation. Here's the stream flow for the for different locations. You can get the SNOTEL sites, the 8-station index. So there's just quite a bit of information here in one spot of knowing what the current conditions look like. The evaporative drought demand index, you can see the 1 month, the 3 month, and how this has evolved over the last 6 months. It can be US wide. So there's quite a bit of information, like I said, about the current conditions. So I think this is a great, if you want to get a sense of how this year is compared to other years, this is a great landing site. It also does provide forecast and outlooks. And so here's the medium range, so 3 to 7 days for precipitation and soil moisture changes. You have the eddy, there's eddy projections now. You can get temperature projections. What Amanda showed in terms of the CPC outlooks from 6 to 10, 8 to 14, but then also the 3 month for temperature and precipitation. New this year is this the NMME, so multiple models run out 30 days, and so this shows each of the different trends in those models. And so this is the combination, so the average of all the different models, but each of what the individual models are showing in terms of anomaly for temperature. So that's maximum temperature, minimum temperature, and then also precipitation. So this is just another way. And again, when you have multiple models like this, if there's more consistency between the models, it's an indication that there's a bit more certainty, even though 30-day forecasts are extremely hard and not always super reliable. And then there's a wildfire outlook and stream forecast. And so these are kind of my general go-to tools in terms of looking at seeing the current conditions, what's coming between the CNAP, the CW3E, and the Great Basin Dashboard. I'm also very happy to answer questions on any of these if you have any. But yeah, so I hope you find them useful this water year. Thank you.
Thanks, Julie. I will switch over to me to wrap things up, but there is one question, and I think maybe, I'm not sure where it came from, if it's anything in particular, but they were just asking how atmospheric wind was measured. They were just curious about instrument. That might be one you could answer why I change over to my slides.
So a lot of what I showed are from model output, and so the model that's where those winds are coming up from is from forecast models. In terms of measuring winds, it's generally hard to do. So in getting them in the forecast, a big effort of CW3E is atmospheric river reconnaissance. So it's similar to the hurricane reconnaissance, where they drop dropsondes in through the storms to get these measurements, and then those are then incorporated into the forecast model. So So they do that with atmospheric rivers, and that helps in terms of the early research has showed that generally helps with the forecast of atmospheric rivers. The other are radiosondes, so it's a similar idea. They're balloons that go up, and CW3 has launched those during atmospheric rivers in Northern California and Southern California. And then there are some wind profilers in certain locations that do measure wind as well.
Great, thanks, Julie. Yeah, so Julie and I were talking about how we wanted to wrap up this webinar because to talk to you guys, the folks, because last year was a dry year. Here's on the right was a figure you saw that Dave presented earlier on about from the Westwide Drought Tracker of looking at the percent of normal precipitation. You see, we currently have drought conditions because a lot of the regions here were dry. We have lower than normal amount of precipitation. And so we were thinking about this, what if this year's dry again? La Niña signals are pointing that way. Is there anything to help us start thinking about and how to help you guys prepare for a second dry year and what that might mean? And so we looked back a little bit back at the 2012 to 2016 drought. That one kicked off by 2 dry years in 2012 and 2013. And in 2013 is when we started to hear some of those things from the state level impacts and things that had happened. And we realized each drought is unique. How it forms and what impacts it has are really dependent on how it forms and the preparedness of people and things like that. But just to get you guys thinking about what happens with a second year, what does that mean for your organization or your region, your water, your things like that. We are looking at the current forecasts are for a dry year, and we are building on top of, at least for quite a bit of the region, an already dry year. I pulled this is from the state of California. They updated their most significant droughts document this year. Just to give you a little bit back from thinking again back to the 2012-2016 drought, around May of 2013, so towards the end of that second wet season, was when we started to have, different types of impacts, especially up to the state level. And it's not that impacts weren't felt before then, and there's already impacts being felt from the current dryness and things like that. Just things sort of start to get elevated when you start to add multi-years of drought on top of each other. And that's, for example, what this table is showing here as well. What happens with multi-year droughts on unmanaged systems, such as for wildfires, non-irrigated agriculture, fish and wildlife habitat get impacted, and unmanaged systems. Small water systems got impacted, irrigated agriculture, green industry, fish and wildlife again, land subsidence, things that really start to kick in the longer duration of dryness that you have. And we are building on that from last year. So for some people, a single year is a drought, but obviously California has been preparing for drought and has these often happen many times. And so, as I mentioned, the difficulty really just comes into the length of the drought duration. And with some of the forecasts we're seeing, we just want to give everyone a heads up to start thinking about their planning and preparedness, especially for different things, even related to soils, reservoirs, groundwater, things like that. And Julie showed this a little bit. I just want to remind folks that we are, obviously, California is well prepared often with their reservoir system and water resources and things like that. And the reservoirs are sitting pretty well in California, in the Sierra reservoirs and things like that. So that's good news, is that they're prepared. And so we're just waiting to see what happens this year to either add on more water or help buffer some of the drought impacts that we've seen already. And so here are just a few resources that'll get sent out either from today's presentation or there are additional resources. We're going to send these out after the webinar with a post-webinar email. So don't feel like you had to write down every single website that you saw today. But some of them coming from the US are drought.gov, the US Drought Portal, the Drought Monitor. I recommend checking out your state climatologist offices, and in California, including the CDEC website that they have, the Western Regional Climate Center, and the Westwide Drought Tracker. Some other tools, the ones that were from CNAP of the Great Basin that Julie showed. Another one is called Climate Engine. It uses cloud computing to let you look at remote sensing and climate and drought data at a point location, so wherever you are interested. The Drought Monitor, and also another one called the US Water Watcher. And then similarly, I'll send this out afterwards. Well, we've got plenty of resources that Julie showed you, or that I showed you in the Outlook for the predictions and forecasts, depending if you're looking at 1 week, 2 week, 1 to 6 week, and beyond. And I was just going to quickly mention here as well, while I have all those tools, and we'll be sending them out on the current Drought.gov and also the relaunch of Drought.gov, which is coming up soon. We'll have those tools and resources a lot more better organized and easier to find, and even oriented towards California and Nevada specifically on the new site. So when that launches, and we'll be sure to let you guys know, you might be able to find a lot of this similar information and tools for your toolbox in one location. And then the last thing I want to mention, Dave mentioned these a little bit earlier. There's different ways to report your drought impacts, and one of them includes the Condition Monitoring Observer Report, or see more. It helps us see more drought. So this is a tool that lets you enter in from 7 different levels of how bad drought is in your location. Based on your experience, you can include a photo, and this information helps, anyone can see it, but also helps the U.S. Drought Monitor authors, people in the states, your state climatologists know what's going on the ground in your region. So we really want to motivate folks to submit observations, because it lets us know what's going on the ground where you are. So we get a sort of a finer detail besides some of the information we're finding through observational data or forecasts and things like that. And so I want to include this here because I want to give you guys, hopefully motivate you guys to include, if you are seeing impacts, to report those and let them know sort of what you're seeing on the ground with drought impacts. And with that, I will pop over to see if we got a few questions. We generally send most of the questions for the end here, but we'll cover a few here. But I just want to remind folks that the recording of this webinar is going to be available on drought.gov and the drought.gov YouTube channel, probably by tomorrow. And the next webinar is January 25th. If you have any questions now about today's webinar, feel free to pop them in the box, in the questions box, and we'll get to them here. But I also want to mention one thing different this winter that we're going to be doing is a drought status update. So more just like a web page or email form of just some of the impacts we're hearing, drought conditions and things in between the webinars. And we're shooting for mid-December-ish to do the first one of those. And then questions. Yeah, people asking about the resources and slides. Sadly, the slides aren't available, but the recording will be posted, and we're going to send all the resources that we can. They'll fit into the post-webinar constant contact email. And so by signing up for the webinar, you'll be added to that list. So we'll make sure you have all the resources. One question I think that I can answer, and maybe Julie can answer as well, it came up earlier, is do most of these websites have readily available GIS data? I can speak to some of those tools that I showed and things like that, and I think the answer is generally no. This is a request we've gotten before, especially for our advanced users who want to be able to use this information in their own platforms and things like that. And so we've heard this before, and so we're working on figuring out, especially with the new drought.gov, where you can grab information or tell you which ones do have available information for GIS and which ones don't, and maybe start to talk with our partners about getting that available. But Julie, did you want to say, do you guys have any GIS information available on CW3E's website currently?
No, we don't currently.
Okay, yeah. And this is a newer request we're getting too, just as users get more advanced in the technologies there.
The one thing, Amanda, I will add is on the CW3E website, I didn't highlight it, but the interactive maps, there's quite a bit of forecast information in terms of precipitation and freezing level at the watershed scale level. And so if you go to CW3E on the home page, kind of halfway through on the far right, there's a link to interactive maps, and that's one place, although we don't provide the GIS data, that you can look at the watershed scale, some of the watershed scale forecast.
All right, I think that's most of the questions that I saw. So I'm going to say thank you to everyone for listening today. As I said, we have a lot of follow-up information to send you all and to share with others in your organizations and partners and things like that. And the recording will be up soon. If you're more interested in learning more about the drought early warning system and some of the other activities that we're up to, please feel free to contact and reach out to me. Otherwise, we hope we'll see you guys again on January 25th for the next webinar to update to see how we've been doing so far in the conditions and forecasts.